To determine whether a motor is set up for 240 volts, 3-phase or 480 volts, 3-phase, measure the voltage between the pairs of wires from each phase. If the voltage between any two pairs of wires is approximately 240 volts, the motor is wired for 240 volts, 3-phase. If the voltage between any two pairs of wires is approximately 480 volts, the motor is wired for 480 volts, 3-phase. Measuring the current at 240 volts, 3-phase and comparing it with the calculated value could be a way to determine the voltage configuration. However, this method is not reliable because the current draw can vary depending on the load and the efficiency of the motor. The speed of a 3-phase induction motor is determined by the following formula: speed in RPM equals 120 times frequency in Hertz divided by number of poles. If the motor is designed to run at 1200 RPM at 60 Hz, it will run at the same speed regardless of whether it is connected to 240 volts or 480 volts, because the frequency remains the same. The motor terminal plate may have a spot for a sticker or label with the wiring diagram. Check thoroughly for any markings. If you have a multimeter with the continuity tester, you can trace the wires from the motor terminals to the input terminals on the machine to determine the wiring configuration. Refer to the manufacturer's documentation or contact the manufacturer directly for specific information on the motor's voltage configuration and wiring diagram. The process of determining the voltage configuration of a 3-phase motor involves several steps, primarily focusing on voltage measurements and potentially tracing wiring. The most direct method involves using a multimeter to measure the voltage between the wire pairs of each phase. Because the motor in question has 6 wires, meaning 2 wires for each of the 3 phases, a voltage reading between the correct wire pairs will indicate the voltage for which the motor is configured. A reading of approximately 240 volts suggests a 240 volt configuration, while a reading of approximately 480 volts indicates a 480 volt configuration. This method is based on the principle that the motor windings are connected in a way that matches the supply voltage, enabling efficient operation. While measuring current at 240 volts and comparing it against a calculated value is mentioned, it is considered less reliable due to the variability in current draw based on load and motor efficiency. Load refers to the mechanical work the motor is performing, and a heavier load will naturally draw more current. Motor efficiency, which varies from motor to motor, also affects current draw for a given load. Therefore, relying solely on current measurements to determine voltage configuration can lead to inaccurate conclusions. Regarding motor speed, the key determinant is the frequency of the power supply and the number of poles in the motor, as expressed in the formula: speed in RPM equals 120 times frequency in Hertz divided by number of poles. For instance, in the United States, the standard frequency is 60 Hz. The number of poles is a design characteristic of the motor. Given a constant frequency and number of poles, the motor's speed will remain the same irrespective of whether it is connected to a 240 volt or 480 volt supply. This assumes that the motor is properly configured for the connected voltage. The additional considerations section emphasizes the importance of checking for any markings or diagrams on the motor terminal plate. These markings often provide the most direct and reliable indication of the motor's voltage configuration and wiring diagram. If markings are unclear or missing, using a multimeter in continuity testing mode can help trace the wiring from the motor terminals to the input terminals, which can clarify the wiring configuration. However, care must be taken to ensure the motor is disconnected from the power supply before performing continuity tests to prevent electrical shock or damage to the multimeter. Finally, the most definitive approach involves consulting the manufacturer's documentation or contacting the manufacturer directly. Manufacturers typically provide detailed specifications and wiring diagrams for their motors, ensuring accurate and safe operation. This is particularly useful when dealing with older or less common motors where information may not be readily available. In summary, accurately determining a 3-phase motor's voltage configuration requires a combination of direct voltage measurements, careful examination of motor markings, and potentially tracing wiring with a continuity tester. Consulting the manufacturer's documentation is crucial for ensuring safe and proper operation. When dealing with electrical equipment, safety should always be the top priority. If there's any doubt about the correct configuration, it's best to consult a qualified electrician to avoid damage to the equipment or potential injury. First, visual inspection. Begin by thoroughly inspecting the motor's nameplate and terminal box for any markings, stickers, or diagrams that indicate the voltage configuration. Look for voltage ratings like 240 volts, 480 volts, or a dual voltage rating such as 240/480 volts. Also, look for wiring diagrams showing how to connect the motor for different voltages. Second, voltage measurement. If the nameplate information is unclear or missing, use a multimeter to measure the voltage between the motor's terminals. With the motor disconnected from the power supply, set the multimeter to voltage measurement mode, alternating current. Identify the pairs of wires corresponding to each phase. Measure the voltage between each pair of wires. If the voltage between any two pairs is approximately 240 volts, the motor is likely configured for 240 volts, 3-phase. If the voltage between any two pairs is approximately 480 volts, the motor is likely configured for 480 volts, 3-phase. Third, continuity testing. If voltage measurements are inconclusive, use a multimeter in continuity testing mode to trace the wiring configuration. Disconnect the motor from the power supply before performing continuity tests. Identify the motor's terminals and trace the wires back to the input terminals. By tracing the wiring, you can determine how the motor's windings are connected. This can help identify whether the motor is configured for 240 volts or 480 volts. Fourth, manufacturer documentation. Refer to the motor's manufacturer documentation for detailed specifications and wiring diagrams. The manufacturer's documentation provides the most accurate and reliable information about the motor's voltage configuration. Contact the manufacturer directly if the documentation is unavailable or unclear. Fifth, current measurement considerations. While measuring current can provide some insight into the motor's voltage configuration, it is not a reliable method on its own. Current draw varies depending on the load and the motor's efficiency. Therefore, current measurement should be used in conjunction with other methods to determine the voltage configuration. 6. Motor speed considerations. The speed of a 3-phase induction motor is determined by the frequency of the power supply and the number of poles in the motor. The formula for motor speed is speed in RPM equals 120 times frequency in Hertz divided by number of poles. If the frequency and number of poles remain constant, the motor speed will be the same regardless of whether it is connected to 240 volts or 480 volts. 7th, safety precautions. When working with electrical equipment, always prioritize safety. Disconnect the motor from the power supply before performing any measurements or tests. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are unsure about any aspect of the motor's configuration or testing procedures, consult a qualified electrician. 8. Dual voltage motors. Some motors are designed to operate at multiple voltages, such as 240 volts and 480 volts. These motors typically have multiple sets of windings that can be connected in different configurations to match the supply voltage. The motor's nameplate should indicate whether it is a dual voltage motor and provide wiring diagrams for each voltage configuration. 9th, winding connections. The motor's windings are typically connected in either star, also known as Y, or delta configuration. This specific winding configuration affects the motor's voltage and current characteristics. Understanding the winding configuration can help in determining the motor's voltage rating. 10th, professional consultation. If you are unsure about any aspect of determining the motor's voltage configuration, consult a qualified electrician. An electrician has the knowledge, skills, and equipment to safely and accurately assess the motor and determine its voltage rating. In the context of electrical engineering, understanding the configuration of a 3-phase motor is crucial for its safe and efficient operation. The motor, rated at 11 kilowatts, represents a significant load and misconfiguration could lead to damage or failure. The initial inquiry stems from the uncertainty surrounding its voltage setting, whether it's configured for 240 volts or 480 volts, after noticing a scratched out voltage rating on the motor's terminal plate. The fact that the motor has 6 wires, with 2 wires per phase, is a common configuration that allows for dual voltage operation, typically 240 volts or 480 volts. The suggested approach of connecting the motor to a 240 volt, 3-phase supply and measuring the current to compare it with calculated values is a method, but as highlighted, not the most reliable. The problem lies in the variability of the motor's load and efficiency, which can affect the current draw irrespective of the voltage configuration. For example, a lightly loaded motor connected to a 240 volt supply might draw a current that seems appropriate, but this could be misleading if the motor is actually configured for 480 volts. Similarly, an inefficient motor might draw a higher current than expected, leading to an incorrect conclusion about its voltage configuration. The correct approach involves directly measuring the voltage between the pairs of wires. This is because the voltage between these pairs should correspond to the configured voltage. If the motor is wired for 240 volts, the voltage between the wire pairs should be approximately 240 volts. If it is wired for 480 volts, the voltage should be around 480 volts. This measurement provides a clear indication of the motor's configured voltage. Regarding the motor's speed, it is important to understand that for a given motor and supply frequency, the speed remains constant regardless of the voltage, as long as the motor is correctly configured for that voltage. The motor speed is determined by the number of poles in the motor and the frequency of the power supply. According to the formula, speed equals 120 times frequency divided by number of poles. Therefore, changing the voltage from 240 volts to 480 volts will not change the motor speed, assuming the motor is appropriately configured for the applied voltage and the frequency remains constant. To determine the voltage configuration, visual inspection should be performed. Look for any markings or diagrams on the motor's terminal plate or housing. These markings often indicate the voltage settings and wiring configurations. If the markings are unclear or missing, the next step is to use a multimeter to measure the voltage between the wire pairs. This should be done with the motor disconnected from the power supply to prevent any risk of electric shock. By measuring the voltage between the wire pairs, it can be directly determined whether the motor is configured for 240 volts or 480 volts. In addition, the manufacturer's documentation should be checked. This documentation provides detailed information about the motor's specifications and wiring diagrams. It can be obtained from the manufacturer's website or by contacting their customer service. Finally, if there is any doubt about the correct voltage configuration, a qualified electrician should be consulted. An electrician has the expertise to safely and accurately determine a motor's configuration and ensure it is properly connected to the power supply. Safety is a primary concern, and it is important to take all necessary precautions when working with electrical equipment. This includes disconnecting the power supply, wearing appropriate personal protective equipment, and following all relevant safety guidelines and regulations. The most direct way to verify the voltage configuration of the motor is to measure the voltage between the pairs of wires. With the motor disconnected from any power source, use a multimeter set to measure alternating current volts. Measure the voltage between each pair of wires. If the measured voltage is approximately 240 volts, the motor is configured for 240 volts, 3-phase. If the measured voltage is approximately 480 volts, the motor is configured for 480 volts, 3-phase. Remember that actual voltage readings may vary slightly due to factors such as line voltage fluctuations and meter accuracy, but they should be close to the expected values. The suggestion to measure current after connecting the motor to a 240 volt supply and comparing it to a calculated value is less reliable for determining the voltage configuration. The current drawn by a motor depends on the load it is driving. If the motor is lightly loaded, it will draw less current, regardless of whether it's configured for 240 volts or 480 volts. Conversely, if the motor is heavily loaded, it will draw more current. Therefore, current measurements alone are not a definitive indicator of the voltage configuration. The speed of a three-phase induction motor is determined by the frequency of the power supply and the number of poles in the motor. The formula is speed in RPM equals 120 times frequency in Hertz divided by number of poles. The frequency is the rate at which the alternating current changes direction, typically 60 Hz in the United States. The number of poles is a design characteristic of the motor. It determines the synchronous speed of the motor, which is the speed at which the magnetic field rotates. The actual speed of the motor is slightly less than the synchronous speed due to slip. Changing the voltage from 240 volts to 480 volts will not change the motor's speed, as long as the frequency and number of poles remain the same. The motor will simply draw less current at 480 volts to produce the same amount of power. Start by visually inspecting the motor for any markings, labels, or diagrams that indicate the voltage configuration. Look for voltage ratings like 240 volts or 480 volts. Also, look for wiring diagrams that show how to connect the motor for different voltages. If the markings are unclear or missing, try searching online for the motor's model number. The manufacturer's website or other online resources may provide detailed specifications and wiring diagrams. If the motor has a terminal box, open it and inspect the wiring connections. The wiring configuration may provide clues about the voltage configuration. For example, if the wires are connected in a star configuration, the motor is likely configured for 480 volts. If the wires are connected in a delta configuration, the motor is likely configured for 240 volts. If you are unsure about the wiring configuration, consult a qualified electrician. An electrician has the knowledge and experience to safely and accurately determine the motor's voltage configuration. Above all, make sure you're safe, or it is better to consult with a professional electrician.